Geeks has a challenge for you, the 390 challenge. Choose what you want to learn in 2024 and aim to complete at least 90% of the course in the next 90 days. And if you do that, you get back 90% of what you paid for the course. We believe you can do that. Now all you got to do is commit to your success. Commit with Geeks for Geeks.
Hello guys, welcome back to our YouTube channel Geeks for Geeks Gate Computer Science. Just give me a quick thumbs up in the chat section if I am visible and audible to all of you. Guys, just give me a quick thumbs up so that we can start our today's session. Let me also see that I am audible to all of you guys. I am audible to all of you guys. Okay, yeah. So thank you, Bhavesh. Okay, so yeah, I am audible. Let me share my screen and just confirm me that it's visible to all of you. Yeah, I hope it's visible. Let me see. Yeah. Okay, so guys, before starting the session, I just want to tell you about this 390 challenge GFG is having for this new year for all the students so that students can be more consistent in the courses and also they can take benefit. So, what this 390 challenge is that you can refund 90% if you buy any course between 1st of January to 31st of January if you complete 90% course in 90 days. So that is a very good thing for all of the students which GFG is catering. So if you do not want it, you can tell your friends and you can share it with any another student which might need it. Okay, so this would be helpful for all of the students. And guys, it would be helpful in your studies as well, because now they are going giving you 90 day, you have to complete 90% course in 90 days. So this is win-win situation for you. You have to complete this course in 90% course in 90 days and you will get 90% refund. So you are getting everything here. You are completing the course, you are getting all the knowledge you want because you have bought that course uh, for completion, right? And because you know that if you will complete it in 90 days you will get 90% refund. So that is also a great thing. Okay, so just keep your procrastination aside and enroll the course. And this is eligible if you will apply from 1st of January to 31st of January. If you buy any course between 1st of January to 31st of January. Okay, so okay, so that's all for this 390 challenge. Let's start this session. So some students are asking some question. Bhavesh is asking how much marks required to come under 200 in data science and AI. How much marks required to come under 200 rank? Okay, so Bhavesh, this is a new exam for everyone. So we can't say that what kind of difficulty exam would be there and how much marks you have to score, because everyone is preparing and everyone is teaching. This is a new course. So that's why I hope you should try to gain as much marks as possible, and then it goes up to that how is the difficulty of the exam and how is the how students are performing in that exam. So all depends on that. Rank basically depends on that, right? So we do not know right now about it, so it would help you first, because for gate computer science everyone knows, because it is happening from past 25 to 30 years. So everyone knows that how much marks should gain how much rank. But right now we do not know that, because we do not know that what kind of difficulty level they are going to ask. Sudhadeep is asking when will the Python AI course come on this channel. So the Subha, you can see that in this crash course we are also having DSA, right? And in this DSA we are working on Python. We are working with Python because we know that Gate data science ask questions from Python. Okay. How much syllabus you covered for data science? And yeah, okay, Bhavesh is asking from Subha. Okay, so guys, you can share that how much you have covered also in the contest. Now I'm getting 45 to 50 marks in test series, and my AI and ML is remaining. So, Bhavesh, if you will see that IISc mock test, you can see that there are lot of question based on machine learning. So you can't left machine learning topic. So just go through that in 15 to 20 days, and then also simultaneously work on the test series. A data science full course will have a marathon session on GFG channel. uh, Isadia, basically we are having crash course for data science and marathon sessions for
Yeah, I hope I am audible. So, Imran, we are having right now, we are having marathon sessions for GATE Computer Science and crash course for this much GATE Data Science. Okay, am I audible, guys? Just let me know if I'm audible now. Just let me check my audio. Okay, guys, I'm audible. Just check. Let's just check it. Okay, so Sophia is asking what is the benefit of GATE DA after achieving good rank? Sophia, basically, GATE exam is for getting admission for 2-year master's program in IITs or IISc. So for GATE data science, you will get that. And also, we'll see that if some PSUs will be hiring. We do not know right now because they haven't shared any information for that. That some PSUs are hiring or taking an interviews based on GATE data science score or not. We already know that GATE data science, civil, all these stream score help us to get into PSUs. Okay, yeah. So let's start our session. So we'll start with basics for today's session, and you can see that we have made a name. We have named this session Introduction to Machine Learning. So first we'll introduce some machine learning topics, and then we'll move to regression, right? So what is machine learning? Basically, what machine learning does, you have heard about that there is so much hype about machine learning right now. Machine learning is a science of programming computers so that they can learn from the data. So that means every time you do not have to program something to do your work, right? So it will learn from the data. You fed some data in the computer and you put some algorithm. So with the algorithm, that data, and with the help of that data, machine learn itself and do your work. Here is most likely general definition. You can see here that machine learning is a field of study that gives computers to the ability to learn without being explicitly programmed. So for each of the work, we do not want to explicitly program. We can take one example. Let's say we have we have number of rooms. We have one data in which we have number of rooms in a house and price of a house, right? Price of a house is given, and we have given 10 to 12 rows. So I have plotted this data set here. So I got this kind of a data, right? So now, let's say I know that if I have two number of rooms, then I know how many, what would be the price of house. And I know that if I have four number of rooms, then I know what would be the price of house. Let's say if I want to know that if I have three number of rooms, then what would be the price of house. So what would I do? I'll work on an algorithm which will tell me that if any kind of room possible, any number of room possible, what would be the price of house, right? Okay, there are some comments. IITs are not having MTech in DA, AI, etc. Sadia, right now they are having some of the IITs are starting, and now because of this exam, after that exam, we'll sure that hear from them that they are opening GATE data science stream. Right, right. So the machine learns by itself. Rajveer is asking that there are lack of questions for machine learning and AI. So basically, GFG has its all India mock. You can take help from there, and also ISC also has machine learning questions, and also I think yeah, we are having mock exam, and with the session, I'll provide you from the next session onwards. I'll try to provide you questions for machine learning. Right, Bhavesh. There are seven IITs having data science and AI branch, and IIC itself has two branches. Okay, so that ability will help me to, without being explicitly programmed, we'll know using machine learning, right? Now, there are some examples of machine learning: spam email filtering. You have already heard that spam email filtering. What is the I want to know that the spam mail, right? The mail which is spam go into the spam section, does not come in my inbox. I have to filter that. So how do I filter that? I'll provide some of the mails data, and I'll tell the machine that okay, these are my spams and these are not my spam mails. So what would machine do? Machine would search that what kind of words we'll use if I have a spam mail, right? So win 10,000 crores, like these kind of words would be there. So they would, machine would mark these words and create an algorithm based on that. Now, what would happen if I'll give a new fresh email? Right? What would it do? It would find out those words which we have given data previously, and the words which they have stored, which are spam email, right? So if these words found in the new email, then it would goes to the spam section. Otherwise, it goes to my inbox section. So that is spam email filtering. Next is anomaly detection. Right, so having a cancer anomaly detection, that means we are having certain kind of appearance. So we can see that, let's say if I want to know that if a patient have a cancer or not, if I want to know that, so based on that we can perform an algorithm. Okay. Now, this is machine learning table, right? You can see that this is a machine learning chart where three types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. What is supervised learning? Supervised learning is a machine learning program in which we have our data, which is uh, which have input feature and output feature, in which we know that what is a dependent feature and what would be the independent feature. That is my supervised learning. Unsupervised learning, in which we do not have any labeled data. So that means supervised learning, we have labeled data. Unsupervised learning, in which we have unlabeled data. Unlabeled data means you can see that spam filtering, uh, in spam filtering, I know that which of the mail is spam, which of the mail is not spam. So that is my label data. Or let's say if I want to know that price of a house, if I have number of rooms given, so I have given number of room as X and price of a house as Y. So this is my label data. I know which is input, what is output, right? Which are my input features and what is my output feature. Email spam filtering also has that the mail is spam or not is my output, right? And input feature is number of emails which I have provided, which are spam, and number of emails which I have provided that are not spam, right? Unlabeled data is, let's say if I have a cluster of data, I do not know which is input, which is output. So unsupervised learning, basically, let's say if I have dots and I have stars. So unsupervised learning basically do a partition between these two, and we know that we have two kinds of data. So that is my unsupervised learning. We do not have any labeled here. Like I do not know what is output and what is input. Reinforcement learning, in which I do not have any data, no data. If I do not have any data, so how do machine learns? So machine learns by doing practical examples. Like if in a game, right? Let's say if I have a game, so machine would play that game, like, so it would learn by itself that okay, this move helped me to win, this move helped me to win. Okay, so unsupervised learning, we have two major algorithm, that is classification and regression. So in today's session, we are going to discuss about regression. The difference between classification and regression is classification is based on uh, regression. We have numerical output like price of a house. And classification data, we have a number of predefined output, let's say 0 or 1, win or loss, these kind of. Clustering and association analysis are a type of unsupervised learning. Right. Yeah, guys, math is going to play a huge role in this paper, right, Bhavesh? Because you can see that machine learning is also completely dependent on mathematics. Once you know all the concepts in maths, then you would be able to able to score marks. And if you will see, there are around 25 to 30 questions only on maths in GATE IISc sample paper, which already they have shared it with you. Okay, now let's discuss about, because we are going to discuss about linear regression or regression in this session. So let's discuss about supervised learning. Learning a model from a label data, right? Label data means, that means we have an input feature and we have a output feature, and there can be number of input features and number of output features. Like I have taken one example, that let's say number of rooms I have given, and I have given price of a house. So we have one input, one output. So this is my supervised learning, right? Because we have a label data. Whereas when we trying to predict a real valued variable, that means we have a real number. The problem falls under the category of regression, right? And when we are trying to predict a categorical variable, that means we have categories, yes, no, 1 2 3, or 0 1, like this, win or lose, or spam or not spam. These kind of data comes under classification problem, right? So this is my supervised learning a model from a label data. That is supervised learning. Regression has a real valued variable and classification has a categorical variable. These are some example. Let's say predicting the result of a game. Some examples of supervised learning are, so just tell me that these are, which comes under regression, which comes under classification. Predicting the results of a game. So results of a game cannot be number, cannot be a real value. It can be either lose or either win, right? Or either first, second, third position they can give, right? All will be categorical. So this would be my classification problem. Classification. Next is predicting whether a tumor is malignant or benign, right? So tumor is dangerous or not. So we have to tell them. So only we have two options, either malignant or benign. So that means it is also a categorical variable. That means classification, right? Predicting the price of a domain like real estate, stocks, etc. So that means we, here comes the price. Price is real valued. Price can be anything, any real number. So that comes under regression, right? Next, last one is classifying text, such as classifying a set of email as spam or non-spam. right? Again, I can categorize them into spam, that is a spam mail or not a spam mail. So that is classification. Classification. Right. So that's how I know that any problem with which in which I'm working is regression or classification problem. Then I can apply the algorithm. Okay. Now, just let me know if anybody have any confusion between classification and regression. Then we'll discuss further about regression or classification. So, guys, I told you that what would I do? Let's say I have 100 emails, right? Let's say I have 100 emails and I have 100 emails and I want to feed these emails to computer, and I want to know, I want to learn that my machine would work on those emails. And I told that machine, okay, it has 60 non-spam, non-spam and 40 spam. 40 spam mails, right? So what would happen if I'll give all these mails to this machine, and machine would learn. And then if I want any new email, what would I do? I'll take any new mail. Let's say I have one new mail EI, and I'll give this I email to this machine, and this will result to me that it is spam or not spam. But because I have provided these 100 emails to learn from this for this machine, I do not know how this machine is performing. Is it performing good or not on the uh, on on the problem? I do not know that it is working on it properly or not. So that's why I'll divide the data into training data and test data. So out of 100 emails, I'll give 60 or let's say 80 emails to learn. To That means 80 emails to learn. That means 80 emails to train, right? I'll keep 20 emails to test, right? What would happen? First, machine would learn from this 80 emails. Then what would I do? I'll give this 20 emails and check that how machine is performing. Machine is giving a correct answer to 20 or 19 emails or 18 emails. Let's say machine is giving only 20 out of 20, machine is giving 15 results correct, right? So I can increase the accuracy by working on my algorithm, right? I can do that. So just try to keep, I just try, I just try to be good at it so that my test results would be better, right? So that's why we'll keep some part of the data for testing. Right. Similarly, you can take a example, price of a house, right? Let's say if I have a price of a house, so I know if I have number of rooms, 2, 4, 6, 8, like this. If I'll give all the data for the training, then I do not know how to check that my algorithm is working properly or not. So I'll keep some of the data for the testing purpose, right? So that's what we have written here, that in machine learning, data is split into training data and test data. So we'll keep a partition here, just keep 80% of the data for the training and remaining 20% of my data for testing. The first split of data, that is the initial reserve data you use to develop your model, provides the training data. So first split of data we'll use to learn uh, by the machine, right? So after you have successfully developed a model based on training data and are satisfied with its accuracy, you can test the model on the remaining data known as test data, right? So that's how we'll divide the data into training data and test data. Now, let's talk about regression, the algorithm which I was talking about from the start. So we'll start with the linear regression. So linear regression works on when we have one input feature and one output feature. That means one X value and Y is my output feature. So you can see that, let's say, I can take the example number of rooms and price of a house. This is number of rooms and price of a house. price of house. So when I have one feature only, one input feature and one output feature, what I can do, I can plot this data, right? Let's say I'll plot X, Y. So let's say for two rooms, I am having price something, let's say 20 or 30 lakhs. For three rooms, I have something like that, and then I have like that. Similarly, I have this kind of a data, right? So I know I have this kind of a data, but let's say if I want to know between any of this data, I want to know what would be the price of room. Let's say if I have five rooms in my house and I do not have that in my data set. So what would I do? I'll plot a best fit line in this data set, right? I'll plot a best fit line, and that best fit line gives me the result for the values which I do not have. Let's say I have one five room value which I do not have. So what would I do? Okay, so what would I do? Okay, so training data splits into validation data always, man. No, it it based on our requirement. We'll if we require validation data, then we'll split that. Otherwise, we do not split that. If there is chances of overfitting or underfitting, then uh, we use validation. Right. So let's say if I want to know the price of five room houses, so what would I do? I'll plot that data and I can see that on this line I am getting, which is the price of a house, which I already do not know. Right. I can know it from the y-axis. Right. So that's how I'll have this linear regression. So linear regression is a way to identify a relationship between two or more variables. So you have already learned this before at your school level. If you want to find a relationship between two or more variables, if in two variables, that would be a linear regression, and use this relationship to predict the number of variables for any given value of these variables. So because we are finding out line equation of a line, so what is the equation of line? You already have heard about it. Ax plus b is the equation of a line, and y is equals to ax plus b, right? So this is basically equation of a line which I have represented with W is a weight and B is a addition. B tells me where to start, right? If I have a line like this, so B is this length, right? And W is slope of a line, right? What would be the slope of a line? Right, sort of y is equals to mx plus c. You can take any of the variables. So wx plus b represents a line, which now, but I want to find out best fit line because w can be anything, b can be anything. So any of the line possible here, right? Any line possible in this data set. I want to find out best fit line. So how do I do that? Slope is equals to 10 theta, right, Saurabh? But right now we do not know the line. We have to find out which slope would work for us for linear regression, right? Yeah, B would be give me the intercept. Y is equals to mx plus b. X is the input variable, Y is my output variable. So here I have one example. Let's say if I have given with the data, age in years and the blood pressure is given. So I have this data. I have plotted that for if a person has a 56 age, blood pressure is 147. So I have plotted this data. And then 49 age, 145 would be the blood pressure. 49 would be the 49 age, something like here, 145 will be the blood pressure. 72 for a person having age 72, I have 160 blood pressure. So I don't, I let's say if I want to know if I a person age 70 or 68, what would be the blood pressure? So what would sort of I don't think that would work like that, which passes through many dots. That is a baseline. I can't say that if it passes through many dots because I can plot. Let's say if I do not work on linear regression, then I can plot a data like this, right? It plot it joins all the line, right? But it would not be the best fit, right? I'll tell you later, but right now let's understand this. So here blood pressure is a dependent variable and age in year is my independent variable. Let's take it as x and dependent variable as y. So I can write down this equation as y is equals to w x plus b, or I can write down w naught plus w1 x, because I want to write all the variables in W naught and W1. So can I write down y is equals to W naught plus W1 x, and here uh, W naught is my intercept and W1 is a slope. So let's say if I want to draw a line, so this line has a uh, slope W1 and weight W naught, right? So now I want to find out best fit line. So that means I want to find out a line which helps me to which would best fit this data. And what does this best fit mean? Let's understand this. Right? Regression uses line to show trend of the distribution. Right. There can be many lines that try to fit the data points as you can see in the scatter diagram. The aim is to find best fit line. So you can see that there are so many lines possible for different W naught and W1. What was the equation? Y is equals to W naught plus W1 x. X is my age and Y is my blood pressure. Hey, but what if the data is not linear? Yuvraj, we'll work on that. I'm going to use polynomial regression for if the data is not linear. If I'm not able to find out best fit line, if I'm getting so much errors, then we'll use polynomial regression for that. I am going to discuss that as well. But first, let's discuss uh, linear regression. Right. So yeah, y is equals to W naught plus W1 x. So for different W naughts and W1, I get different line because x and y are fixed. X is age and y is blood pressure. For different W naught and W1, I get different values. So which line I would consider as my best fit line? Best fit line help me that minimize the total error. So guys, as you can see that, let's say if I have this line, right? So you can see that if I am talking about this line, so this would be my error, right? So this would be my error. This is my error, and these are my errors. So to consider those error, let's say y cap is equals to W naught plus W1 x, right? So what is this y cap? Y cap is my predicted value. Predicted value. Y cap is my predicted value, and y is my exact value or actual value. So I want to know what would be the error in this case. So how would I know the error? Because you can see that how many data points I have given here. Just a minute. So you can see that I have given here 1, 2, 3, 4, 5, 6 data points. So if I write down y cap here, I get some value here, 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 some value here. So I want to know the error. What would be the error? Error would be y minus y cap. Error would be y minus y cap. But you can see that in the line, if I'll see, some error would be positive if I write down y minus y cap, because this is y, this is y cap, this is y cap, and this is y. Some error would be positive, some error would be negative. So what would I do? Instead of taking summation of all the error, I'll take a square. I'll take a square. Why I am taking a square? Because I do not want to ignore any error because of positive and negative signs. Guys, just remember that why I am taking a square for the error function, because I do not want to uh, lose any of the error value from the positive and negative sign. So that's why I have taken a square, so that all the errors will become positive. And I'll use 1 by 2 in denominator. Now you would ask that why I am using 1 by 2 in denominator. Anyone have any idea that why I am using this 1 by 2 in denominator? Just let me know, guys, if anyone have any idea that why we are using this 1 by 2. Guys, we are going to use gradient descent to minimize the error. What would I want here? I want as much less error as possible. So that means I want to minimize this error. And if you remember, if you have worked on calculus or optimization in calculus, so you would know that to find out minima or maxima of a function, you use derivatives, right? To find out minimum value or maximum value, you use derivatives. And because of that derivative, uh, if I'll take a derivative of this error function, y minus y cap square, that 2 would come in front, so 2 and 2 would get cancelled. So that's why I have taken 1 by 2. Basically, for ease of calculation, I have taken 1 by 2 here. Just let me know if anybody have any confusion. How do I get this error function? 1 by 2 summation y minus y cap square. And I can write down I varying from 1 to n if I have n data points. If I have n data points, I can write down here. That would be my error. And here my goal is to find out, to minimize this error. And if I'll get minimum error, the W0 and W1, which uh, the values of W0 and W1, which gives the minimum error, which would be my best fit line. So minimize the error. So I can write down here what would be my error. If I'll write down, is this mean squared error? Right. This is a mean squared error. So I can write down 1 by 2 summation I varying from 1 to n y minus, what is y cap? Y cap is W0 plus W1x square. So that means here my aim is to find W0 and W1 minimizes the error function, right? So I hope this is clear. Let's see how do we minimize the error. So what we have done, we have defined the cost function W0 comma W1, and I also represent with JW comma B, or let's say JW0 comma W1. It's up to you what representation you use and what would be in the question, right? So JW0 comma W1, J represent my cost value. So this is a function W0 plus W1 xi. Right? So you can write down here xi as well, because xi's are my data points and this would become y, right? So this is my jw0 comma w1 cost function, right? So guys, one thing we know, to minimize a function, we find out a derivative, right? And then with the help of that, we'll use second derivative test to check that the function has a minima or maximum, but it does not work every time. So that's why we have one method to find out minimum value, which we call as gradient descent. So guys, do anyone have any idea what is gradient descent? Just let me know, guys, if anybody have any idea about gradient descent. Okay, so gradient descent is an optimization algorithm for finding a local minima of a differentiable function. So it is an algorithm optimization to find out maximum or minimum value for finding a local minima of a differentiable function. So it helped me to find out local minima for a differentiable function. And I know that if I talk about, I have to minimize this function 1 by n summation I varying from 1 to n yi minus w0 plus w1 xi square. So how do I find out minimum value for this using gradient descent? Just understand this gradient descent very carefully, because we are going to use it so frequently in machine learning, gradient descent. So can I write down this as jw0 comma w1, and I have to minimize this. So how do I minimize this? So what would I do? Let's say I'll find out first derivative del j by del w0, right? I'm finding out partial derivative. So guys, I told you that you would be good at maths to find out work on machine learning. So I hope all of you know how to find out derivatives, how to find out partial derivative. So if I take partial derivative del j by del w naught, so 1 by n remains same, summation I varying from 1 to n remains same. Let's differentiate this. So if you remember, differentiation of x square would be 2x. Global minima slash local minima. Uh, Sadia, right now we are working on global minima. We are working on local minima because it's not possible using gradient descent that we'll be able to find out global minima. Because I'll tell you how global minima works uh, after this slide because there I have drawn a diagram. So I'll tell you that gradient descent only helps me to find out local minima, right? So I'll tell you how gradient descent algorithm works. So del J by del W naught, I'll find out a differentiation. What would I get here? 1 by n remains same, summation remains same. I'll differentiate this. So it would become 2yi minus W naught plus W1 xi, and then I'll differentiate this initial function, right? This inner function. yi differentiation is 0, w naught differentiation is 0, minus w1 xi differentiation would be minus, sorry, yi differentiation is 0, w naught differentiation would be minus 1. Del j by del w naught differentiation would be like this. Then I'll differentiation with respect to 1, del j by del w1, right? So what would I get? 1 by n summation I varying from 1 to n 2 yi minus w naught plus w1 xi. And then we have a differentiation of yi is 0, w naught 0, w1 xi minus w1 xi differentiation would be minus. Right, so we get here partial derivatives del j by del w naught and del j by del w1. Let's understand the mathematics, then I'll tell you practically how gradient descent works. So I have to find out the values here for w naught and w1 such that find the main aim here, my aim here is find w naught and w1 such that I'll get minimum value of such that we minimum we find we get minimum value of j w naught comma w1. I want to do that, right? So what would I do? Because I get here partial derivative del j by del w naught, del j by del w1. So gradient descent works in following step. Initialize the parameters to some random variable. So at the start we have some j w naught comma w1. So let's initialize, let's say W naught 0 and W1 1. Let's take any value, right? So first you would initialize JW naught W1. You would find out some value for JW naught comma W1. Then you would find out gradient of cost function with respect to parameters. These are nothing but gradients. Gradients of cost function. You would find out gradients of cost function. These are my gradients of cost function. You would find out that, and then you would work on you would find update the parameters in the third step. This is first step. Second step would be you would find out gradients of cost function, and the third step would be you would update the parameters. And how would you update the parameters? W1 would be W1 minus alpha del j by del W1, and W2 would W naught would be W naught minus alpha del j by del W naught. So you can see that we are we are subtracting W1, subtracting some value out of W1. And we have taken here alpha. This alpha is nothing but a learning parameter. Learning parameter. So with the help of gradient, we are going to update the values of W1 and W naught. Now, next fourth step would be because we got new W1 and W naught. I'll find out JW1 comma W naught, and then I'll again find out W1 and W naught new values, right? By updating these, right? So we'll perform these steps again and again. This is my uh, recursive algorithm. So first I'll find out W naught, and I'll take, let's say I'll have taken W naught is equals to 0 and W1 is equals to 1 here. And then I have updated the parameters using these steps. So let's say I get here 0.5 as W naught and W1 is 1.2. I got something like that. Now for the fourth step, using W1 and W naught, I'll find out JW1 and W naught. First of all, because we are working on gradient descent, new JW1 comma W naught should be less than the previous one because we want to decrease the values. We want to decrease the value of a cost function or error function, right? We have to decrease the value. If it is increasing, so if it gets increased in any of the step, then we should stop there because our algorithm is not working properly, or we reach the exact minimum value, right? So that's why, uh, what would we do? We'll find out JW1 and W0. I'll check that, okay, the previous cost function would be less than the new one. Then I'll update again. I'll find out again new W1 and W0 by using these learning rate and the gradients. And then I'll work in recursive manner. So what is happening here? Let's say this is my curve for JW naught comma W1, and I'm, because of initial value I have taken W naught comma W1, I'm getting this value JW naught comma W1. I want to take a minimum values of W naught and W1 so that I'll get a minimum error. So I want to reach here. So what would I do? I'll take some values of W naught and W1. I'll update W naught and W1. I'll reach here. Then I'll update again. I'll reach here. I'll update again. I'll reach here. At this point, my W0 and W1 either gets updated or my J gets start increasing. Then we would not get. Then we'll consider at that point. I'll consider a minimum value, and uh, as my final parameters, right? So what does this alpha mean here? I told you about del J by del W, and these are gradients. What does this alpha mean here? Alpha is a learning parameter. So what basically alpha does? Because sometimes we have this cost function, or let's say error function, has very small del J by del W naught. So it updates uh, in very small steps. You can see that how many steps I have to take to reach here. Sometimes our value is del J by del W naught is very large, so that it would uh, it would moves like this, right? We would never be able to get a minima if I'll move something like that, right? You can see that I'm not able to reach here if I'll take so much large step. So that's why we'll take a perfect learning step, right? So that's why alpha required, so that we'll have a perfect learning rate, so that we are able to, our algorithm would not take too much time to reach to minima, or we would finally reach minima. There would be no large steps, so that we would not be able to reach minima. So I hope it is clear. You can see that here I have a function. Here I have JW naught comma W1. And also one more thing, guys, we also call this as loss function as well. Loss function, cost function, error function, any of the name. So you can see that we are trying to approach to minimum value here, and we are decreasing W naught and W1 here. So you can see that we are taking something out of W0 and W1. Let's say these derivatives are positive. You can understand this. What is updating parameter W0 is equals to W0 minus alpha del J by del W0. This parameter would always be positive. W1 would be W1 minus alpha del J by del W1. Okay, guys, I think I'm audible, right? Just let me know if I'm not audible. Okay, so yeah, yeah, I am audible. Okay, so you can see that, let's say these derivative del J by del W naught are negative. Negative value, and del J by del W1 are negative value. So can anyone tell me what does it mean that if derivatives are negative, what do I get? That function is increasing or decreasing? Just anyone have any idea? So we know that if derivatives are negative, then my function is decreasing, right? If derivative is negative, uh, then my function is decreasing, right? So that means if I'm getting my derivatives negative, so I am at this position. So I have to add something to W naught and W1 to reach here, right? So these derivatives would be negative. Alpha is always positive, minus, minus, plus. So we would add W naught and W1 to reach to this position, right? Similarly, if I am here, then my derivatives would be positive because my function is increasing here. You can see and so because they are increasing, so that's why we have to because function is increasing, derivatives would be positive, and I have to decrease something to W naught and W1 to reach here. So you can see that we are decreasing here because in that case del J by W naught, del W naught would be positive. I hope this is clear that how your function JWB gets minimized using gradient descent. Just let me know if there is any confusion in this. Okay, so that's how gradient descent work, and perfect learning rate would be required because uh, if you do not have a perfect learning rate, then it would take too much time either to reach to a minimum value, or either we'll move like that and we are not able to get minimum, like we will move like that, right? So that's why perfect learning rate is required. Learning rate basically controls how big step you take while updating the value W naught and W1. Okay, yeah. So how would we make sure that our gradient descent is working properly? How would we know that gradient descent is working properly? I told you that in each of the updating JW naught and W1, let's say first I'll get W naught is equals to 0. Initially, I have taken this, W1 is 1. Every update makes JW not W1 would be decreasing function, right? You should get this kind of a curve for gradient for JW naught comma W1, JW naught comma W1. So what do I mean here? That JW naught comma W1 would be a decreasing function. Then you can make sure that gradient descent is working properly. This cost function should be decreasing because let's say at any iteration it starts increasing, then your gradient descent algorithm is not working properly. So that's why we can say that in each of, if I'll take here number of iterations on the x-axis and y-axis, I plot JW naught comma W1, I'll get a decreasing function. So uh, now somebody asked me that where should we stop if it is a decreasing function. So we can stop at that point where I'll get very minor error in J value. So you can see that here if I'll move till here there is a J is decreasing, but if I'll move from this point onwards, you can see that there is a very minor error. There is no harm if we would stop at this iteration. Right, so how can we make sure that gradient descent is working properly? This kind of question can come in the exam, that how can we make sure that this cost function always be decreasing. So I hope this is clear. You can ask me if there is any confusion. Oh, hello, ma'am. I have just started 2025 GATE preparation. How many hours to devote every day? Just want to know that you are preparing for GATE computer science or for GATE data science to answer this question properly. So, guys, this is how linear regression works. Just let me know if there is any question for computer science. Like, I'll tell again, I have told this many times that computer science has a very vast syllabus. So students start early or not, it it is very important that you should be consistent, because I am teaching from past 3.5 years, and I'm seeing that students are coming to me at the last moment and seeing that would they be able to complete their syllabus in 2 months and as well as they can practice. That would be a problem for them. So, just want to suggest you that it's not possible for GATE exam to prepare for in last 2 months. You can brush up all the topics if you have studied it before in last 2 months and work on test series and practice questions. You can do that. So that's why plan accordingly so that you would be able to complete your syllabus up to September or October month. And because you are preparing for 2025, you have a lot of time, right? So plan accordingly. Like you have 11 subjects. So uh, to complete the syllabus up to September and October, let's keep it September. And if it gets to October, then that would not be a problem. So if I talk about September, then you have 9 months. So you have to complete in 9 months 11 subjects and also keep revising each of the subjects. So how would you do that? Just try to take 20 days for a subject and just plan accordingly. Which type of question may come in data science kit? Sadia, for that, you can go through the IISc sample paper, which they have already shared, and also we are having our All India mock. We have that in December month, as well as we are going to have in January month as well. And also from the next session onwards, I'll try to share questions with you so that you can practice for machine learning, because I already have so many students asking for questions. Okay, yeah, let's move forward. Now, next thing we have is multiple regression. So we have worked on linear regression. Let's just clear that what we have worked in linear regression. So what we have done, we have one input feature, we have one output feature, and then we got one best fit line, and we called that line as we name that line as y cap is equals to w naught plus w1x, right? And y is my actual value. I want to minimize the error between the actual value and the predicted value, so that's why I have one cost function. I have framed this cost function, which I have given 1 by n summation I varying from 1 to n, and this would be w naught. Why I haven't taken half in this cost function? Let's take this as 1 by 2n. If I'm not taking it as 2, that would not be a problem because I'll not get here 2. In some books, they would divide the cost function as 2 so that they would cancel out this 2. Otherwise, you can keep it like this as well, right? Yeah, so this is my cost function w y minus y cap square, right? So this is my error function, and also if I'll write down this error function, summation I varying from 1 to n y minus uh, w naught plus w1 xi square, right? So this would be my error function. Now I want to minimize this function, minimize jw naught comma w1. That means I want to find out w naught and w1 parameter to such that I'll get a minimum of this value. And these w naught and w1 would give me best fit line, right? So what would I do? I'll use gradient descent for that. I hope now this is clear, right? Now, how this multiple regression work allows a response variable y to be modeled as a linear function of a multi-dimensional feature vector. So what does it mean? Let's say if I have so many input feature x1, x2, x3, let's say I have x8 input feature and I have to predict the value y. Then how would I work on regression? So instead of previously we have find out a line which we have written down w naught plus w1x. That is my line. Here it is a if I have three variables, then it is a plane. If I have four variables, then it would go to a 3D picture. So if I have eight variables, eight input features here, I'll write down y is cap is equals to w naught plus w1x1 plus w2x2 plus w3x3 up to it goes to w8x8. Let's take these values mm. So I'll write down wmxm. So can I write down this as w naught? Instead of 1, I can take here w naught x naught. And let's consider this x naught value as 1. I just want to write down it as a vector because I do not want to write down a so big line. So that's why I'm writing w1x1 plus w1x wmxm. So can I write down this as w naught, w1, wm, and this as a vector, or I can say that matrix, and this one as x naught, x1, x2, xm. So you can see that I have taken a transpose of w vector. So I can write down this as w transpose x. And w is what? W is this vector w naught, w1, and w1. Right? So I want to find out these w naught, w1, wm to find out the best fit line. Right? I want to find out a best fit line. Best fit line, again, for best fit line, I'll work on the error function. Error function would be y minus y cap square upon, because let's say if I have n data points, I can write down this as 1 by n. And I can take 2 for my use. If it is not required, I can drop it as well. It's up to me. Right? I have to minimize this error. Now you can see that if I have one input feature, then I have to find out two parameters. Now I have m input feature. Now I have to update m plus one input features using gradient descent. So I have to work for each of the parameter for w0, w1, w2, w3, w1. Right? So all works like that. You just have to update number of parameters, m plus one number of parameters. I hope this is clear how multiple regression works. Right, so how this W naught gets updated? If I'll work on gradient descent algorithm, gradient descent, how this W naught gets updated? W naught would be W naught minus alpha del J by del W naught. What is J? J is this line, right? Similarly, I'll update W1. Let's take it as WI. And WI would be WI minus alpha del J by del WI. I varying from 1 to n. Right? That's how I'll work on gradient descent. So as many input features are possible for multiple regressions as we want. But because of complexity, we do not take, we have feature scaling or we have uh, principal composition analysis in which we reduce number of features. We'll discuss it later. But right now, let's see how this multiple regression works. Just let me know, guys, if this is clear to everybody. Guys, if there is any question, just let me know. Okay. Now, next thing is polynomial regression. Somebody asked me previously, let's say if I do not have a linear data, if I'm not able to fit a line or if I'm not able to fit a plane, if I'm not able to fit a linear data, so what would I do? As you can see here, I have one input feature and I have one output feature. What would happen if I try to fit a line? So you can see that if I'll try to fit a line, I would not get any help here, right? You can see that this line, because we are getting, you can see that it is giving us in four values, it is giving us true value. Otherwise, we are having error. So we have, if I'll find out a value of the error, like if I'll find out here j w naught comma w1, this would be a very large value, right? So that's why I can see here that linear function does not work here. So that's why I'll introduce one polynomial function. So instead of Uh, Previously, I have represented y cap as w naught plus w1x. This is green one. This is for green line. Instead of that, I'll write down for blue line, I'll write down w naught plus w1x plus w2x square, right? So this would work. This is my blue line, blue curve, right? So this would be the best fit for the data set I have here. So that we call as our polynomial regression, in which we'll take polynomials instead of linear values, linear functions, right? So you can see here I have taken x square. In this, I have to find out w naught, w1, and w2 using gradient descent. Everything else would be same, just the function y cap change here with x square. We have x square here. And guys, one more thing, if I'll add polynomial degree. If I'll increase the polynomial degree, if I'll take y cap is equals to w naught plus w1 x plus w2 x square, w3 x cube, and I'll take w4 x to the power 4, w5 x to the power 5, and w6 x to the power 6. If I'll increase the number of if I'll increase the degree of a polynomial, then it will exactly fit the data. But we do not want exactly fit. Why we do not want exactly fit? Can anybody tell me why do I not want exactly fit data? Why this red line does not work for me? Why I'll go for blue line, blue curve? Why this red curve does not work for me? Anyone, guys? Can anybody tell me that why red curve does not work for me? Red curve does not work for me because you can see that it is exactly fitting my input data, right? It is exactly matching my input data. But let's say if I'll give a new value to this curve, it would not give me the correct results, right? I told you about train data and test data, train and test data. So if I'll give val if it is fitting perfectly to my train data, it would give me error for my test data, and that I do not want, right? So I want perfect data, perfect fit, right? It would not be my perfect fit. So guys, uh, let me tell you that I have two types of error. So I told you that I have training data, training data, and test data, right? If if my curve is not performing, if my algorithm is not performing well on training data, in training data, if I'm getting error, so that would be high bias. And if I'm getting large error in test data, that means I'll get high variance. High bias means that we are getting error in training data, error in training, high error in training data, and high variance means error in test data, right? And I do not want any of them. I do not want high bias and I do not want high variance. I want a middle value between them. So you can see that here when I have started underfitting, so you can see that this condition we call as underfitting, underfitting, because you can see here why it is underfitting, because I'll get here high bias. Why I'll get high bias? Because I have so much error here. So much error, so much error. Every term is giving me error, right? And if I'll go for this red line, red curve, this is what this case is. Red curve is high variance because it is performing good on my initial data, on my training data, but it would not perform on my test data because it is exactly uh, fitting the data, right? So that's why this blue line works, because this is not high variance and this is not high bias. So you can see that if I'll plot a JWB, J, if I'll plot a cost function here, so you can see that cost function shows uh, if I'll take complexity of a model, right? Complexity of a model. Complexity means that if I'm taking a polynomial function, I have to decide na, up to which polynomial I have to take. It is quadratic, cubic, or 4 degree, 5 degree. That what degree that polynomial would be. So if I'll, you can see that in previous data when I have taken a linear model, that means then I have high variance and high bias. I got high bias. But when I'm taken a quadratic polynomial, then I get the best results. But when I have increased the data, I got high variance, and I do not want high variance and high variance. I want good models. So in which case I got good models. In this blue line, I got good models. So it is important for me that I'll not underfit my data. I'll not overfit my data. Guys, do you understand what is underfit and overfit? In underfit, I got high bias, low variance. And in overfitting, I got low bias and high variance, right? High variance means that it is not performing well in my test data. High bias means it is not performing well in my test data. And I do not want any of these. I want a middle thing, that it would be good bias and good variance, low bias and low variance. So where would I get that? I get that in this middle condition. So if I'll go this is high bias underfitting, it is just right, and it is high variance overfitting. So this kind of, so it is important that we would know that up to which degree we have to take a polynomial. And how do I know that? I'll try with different polynomials. That's the only thing I can do. Okay, so guys, that's all I have based on regression. Just let me know if there is any question. Otherwise, we'll discuss we'll discuss in the next class, which will be on Friday. Guys, is there any question? Just let me know. That's all from my side because, and guys, one thing I just want to tell you about 390 challenge. If you will be keep consistent for 90 days, and if you will complete 90% of the course, we'll give you 90% of the money which you have given in the course, of which you have given. Numericals will be on which topic, ma'am? Sadia, there are lots of questions like mathematics would be completely numerical. Like we have three subjects of mathematics. Can we achieve high bias and high variance together? Okay, so numericals will be on mathematics, and also there would be some numericals on machine learning as well when we'll discuss about uh, KNN, or we'll be discussing about neural networks. You will see that there are so much of numericals would be there. And also we can have high bias and high variance if it is not performing, the algorithm is not performing good on our final on our test data as well, then we'll have high variance. Okay, yeah, so that's all from my side, guys. Just okay, you can let me know if there is any question. Otherwise, we'll discuss it in the next class. Right, right. Okay, so yeah, that's all from my side, guys. Thank you. Thank you for joining. Let's end this stream.